Greetings, I'm Professor K, and in this short video presentation we're going to have an introduction to Nmap. Nmap is short for Network Mapper, and it is a network scanning and host detection tool that is very useful during several steps of penetration testing. Nmap is not limited to merely gathering information and enumeration, but it is also a powerful utility that can be used as a vulnerability detector or a security scanner. Nmap is a multi-purpose tool, and it can be run on many different operating systems including Windows, Linux, BSD, and Mac. Nmap is available for both the command line interface and the graphical user interface. The graphical user interface is known as Nmap. For this lab, I'll be using my installation of Kali Linux and another install of Metasploitable 2. For this lab, I have both of my machines configured with their networking set to host-only adapter. If you need to update your installation of Kali, just pull down the choices that you have for adapter and change it over to bridged adapter, and then you'll be able to update. Once you're done updating, go back in and switch it back to host-only adapter. The reason I like using the host-only adapter is that it isolates my installation of Kali and the target machine into their own networking environment, and it does not intrude on my host networking environment or my home network. Using the ifconfig command, I have checked the networking address for both of these machines, the Kali and my target, and I see that they're both using the 192.168.56 network. The last thing I need to do before we get started with the lab is confirm that I do have network connectivity between my Kali machine and my target. To do this, I'm going to do a ping from my Kali machine over to the target. My target's IP address is 192.168.56.101. I'm going to go ahead and just hit enter, and I see that I am getting positive returns. To break the sequence, I will do a Control-C. To clear the terminal in Kali, I just use the clear command. On a Windows machine, it would just be CLS. Nmap is as complicated as you want to make it. It can do basic scanning, and it can do sophisticated scanning using a number of different switches, scripts, and its engine, which we will see in a future lab. In this first example, I'm going to scan a single host, which will be my target. And this is just a basic scan. That's all it is. I'm not using any switches. I'm using the Nmap command followed by the IP address of the target. And if I hit enter, you'll see that it comes back and it gives me all the information about what ports and services are currently running on this address. Nmap was able to determine that the target machine is a virtual machine running on Oracle VirtualBox using a virtual NIC. I can use my up arrow till I come to the clear command, and I'm back to my prompt. To scan an entire subnet, I can type in Nmap followed by the IP address I want it to start with in that subnet, and then I can give it a /24, which is CIDR, and that stands for the subnet mask that we want to use so we can identify what portion of the network will the host IP addresses be located in. Now, I could also type this out as the subnet mask, like so, and that's the same thing. And what we're saying here is the last octet is the only octet that you have to worry about. The /24 tells Nmap that the first three octets are already taken and are full, and there's no need to look there. We're telling Nmap that the only octet that you're going to worry about is the last octet, and that is where the host IPs will be located. So I can go back. Again, I can just slap in the /24, and this just tells Nmap that I want you to scan the entire network, but only look in the last octet for anything to do with host IP addressing. And if you look at the results that you returned with your Nmap scan on this network, you'll see that it tells you it scanned 256 IP addresses. It found 4 hosts, and it completed the scan in the following number of seconds. And it said it scanned all 1,000 ports on 192.168.56.102, but those are closed. Now that's because Nmap is not capable of scanning its own host machine. So whatever you're running Nmap on, it won't be able to scan that machine. So it came up and it found a scan for .100 and 56.1. In this next example, we can see how we can scan multiple targets. So I want to scan just 2 targets with this particular command, and those 2 targets are identified by their IP addresses. So I'm going to scan 192.168.56.1, and I'm going to scan 192.168.56.8. Hit enter. In just a moment, it's going to come back with the results. Now, it did not find the 56.8 address. It found one host, and that would have been the 192.168.56.1. In this example, I'm going to have Nmap scan a specific range of IP addresses, starting at .1 all the way up to .100. To do this, I've just typed in the starting IP address of 192.168.56.1. I'm going to put in a dash, and then I'm going to type in the ending IP addresses, and now Nmap will scan all the IP addresses from .1 all the way to 100. It comes back and it gives me the results. And it didn't find a whole lot here, but we didn't expect that because there's actually only 2 really live machines on this network, this Kali machine and my target machine. But if there had been machines using the range of 192.168.56.1 consecutively through to 100, those results would have been present. Nmap comes with many different switches that can be used to obtain a number of different results. In this first example of using a switch, we're going to use the small letter S capital L switch to generate a list of all the IP addresses to be scanned. So I've typed in Nmap, give it a space, give it a dash. Now you add in the switch, give it a space, type in the IP address or the range of IP addresses that you want to scan. In this case, we're back to scanning the entire subnet of .56.1 all the way up to .256. So I'm going to go ahead and just hit enter. Let's see what happens here. And now you see that we have generated that list of all the IP addresses that we want Nmap to scan. We can also exclude IP addresses that we don't want Nmap to scan. In this example, I've told it that I want you to scan my entire subnet, but I don't want you to scan .1. Go ahead and hit enter. Since we do not have a DNS server on this network, we can ignore the fail to resolve. When it talks about resolving, it's talking about resolving an IP address to a host name or a host name to an IP address. And that's what you use DNS for. So we can ignore this error message. And you'll see that it scanned all the way up to .101. And this is the results that we have from this scan. Down here at the bottom, we see that it scanned 255 IP addresses. And if you'll remember, it normally comes back and it tells you that it scanned 256. But in this case, since we told it to skip that first IP address, it was only going to be able to return results for 255. Everyone who does pen testing or hacking has their own set of favorite techniques for using Nmap. Everyone has a different set of switches that they like to use. They like to get a certain amount of information and they want the information displayed in such a way. And so everybody develops their own favorite Nmap commands and scanning techniques. In this first scanning technique, we're going to use a very popular scanning technique called the SynScan. Now the SynScan is very popular because it doesn't generate any log files on the receiving target. Now the reason that is because the handshake that is normally established between this machine and the target machine is not completed. Since that's the case, then there will be no log attempts generated on the target machine, which allows us to remain stealthy or anonymous. So I'm going to go ahead and hit enter, and it comes back and letting us know that the command completed, and this is what it found. There will be times when you will not be able to use the SynScan because you don't have root privileges. If that's the case, then you're going to have to use the following command. This is called the TCP connect scan. And for this, we're going to use the dash small letter S capital T switch. Now this is going to complete the connection. So this will generate log files. But it's just one of those things that you're going to have to figure out if you're going to use it or not. And if you don't have root privileges on the machine, then of course you're going to have to move up to another command. In this case, it is the TCP connect command. Now, it should be noted that this is only going to scan for TCP ports. We'll use another command later on to scan for UDP ports as well. So I'm going to go ahead and hit enter. And you see that it comes back with some really nice results. But this did complete the connection, so we did generate a log file. This following command is going to scan for UDP ports only. So in our previous scan, you saw how we scanned for TCP ports. Now we're going to scan for UDP ports. So I'm going to go ahead and hit enter. If you want to know what the status of an Nmap scan is, because it's taking a long time, all you have to do is hit enter, and it'll come back up and it'll tell you the following. It'll tell you the stats, how many machines have been scanned, and how long it's taken, and how much longer it's going to take. Sometimes a normal TCP SYN scan is not the best solution because of the firewall. Also, IDS and IPS filtering can block the SYN packets from reaching their destination, the target. A fin scan sends the packet with only a fin flag, so it is not required to complete the TCP handshake. And if that's the case, then no log will be generated. But if they do configure the IDS or the IPS to either warn or block because of a fin flag, then this won't work either. So we're going to go ahead and hit enter here. And it comes back and the command completed successfully. But then again, I don't have a firewall. And again, I don't have an IDS IPS in place. In this next command, we see that we can configure Nmap to perform a simple ping test. Now this is not going to return any results about ports or services, but it will tell us whether or not the machine is up and available on the network. So we're going to use this dash small letter S capital P command to have Nmap ping the target. I'm going to go ahead and hit enter. And it comes back and it says host is up. The MAC address, it returns that, and it tells us that it is an Oracle VirtualBox with using a virtual NIC. This next command uses a combination of a SYN scan and a version scan to determine what versioning of software is currently running on the target machine. So we're going to first conduct a SYN scan, and we're going to find the ports, and then the V is going to be able to tell us what version of software is running on those particular ports. So I'm going to go ahead and hit enter. When the results come back, you see we have the port, the state of the port, the service that is running on the port, and the version of the software. So this is very useful for finding vulnerabilities on the target machine, because once we find that these ports are open running a certain service, we can then determine if that particular version of that software is vulnerable or not. Another very useful Nmap switch is the dash capital O. This is going to come back and give us all the information that Nmap can find about the current version of the operating system that is running on the target. Let's go ahead and hit enter. So down here at the bottom, you'll see that the OS detection was performed. And it tells us that the OS is running Linux kernel, and the OS details, it is running Linux version 2.6.9 through 2.6.33. Now, that's information that you need to know about if you're going to try to attack this machine and go after the operating system. So OS fingerprinting is a very popular technique, and it can be used to discover routers, workstations, and the like. It also tells you the operating system that is running on the machine, and it gives you other OS details. It also gives you the network distance. In this case, it tells us that it is just one hop away. If the target is filtering out connections using a firewall, an IDS, or an IPS, we can use the following PN command to ensure that we do not ping to find the remote operating system. The dash PN tells Nmap not to ping the remote computer, since sometimes firewalls will block the request. So I'm going to go ahead and just hit enter, see what happens here. Now there will be times that Nmap will not be able to determine what operating system is running on the target for a number of reasons, probably too much information or not enough details. There's a lot of different reasons why you'll get that command of too many fingerprints match this host to give specifics on the OS details. If Nmap cannot detect the remote OS accurately, you have the option of using the Nmap's guess feature. This will come up with as much information as it possibly can, and it will make its best effort to guess what the operating system actually is on the remote target. I'm going to go ahead and hit enter. Here in the results we see that it found something to do with a Windows operating system, but it can't really determine what the operating system is, so it's going to come back with its best possible guess, and that's all you can hope for if it doesn't have all the information that it needs. This video and lab provided a good overview or an introduction to Nmap. Now there's a lot more to it. If you were to go to the internet and download the Nmap user guide, you would have to go out and purchase about a 4-inch 3-ring binder, and that might not be big enough. That's how powerful this utility is. That's going to conclude the short video presentation on your introduction to Nmap. Now if you have any questions or concerns about any of the material that was covered in the lab or in this video, please do not hesitate to reach out and contact your instructor, and I'll see you in my next video.